security defense team, trust and assured microelectronics program, and so we had to go on Redstone base for some of those meetings. But that the facility is like that's back in the middle. You're driving and you're driving and you're driving. It's like, is that it? Not sure. But yeah, that was right before the pandemic rolled around.
Okay.
It's been a while.
So it was pretty busy in Barstow. Yeah, it's starting to pick back up now, a little quieter.
Yeah.
But I think probably when you were there, I think there was probably somewhere around 50,000 people go through the gates a day, something like that. A lot of activity.
That's significant. Wow.
FBI's been ramping up. I just heard the other night that they're looking to have 2,000 people there by the end of this year.
Wow.
Yeah.
It's phenomenal.
40-acre complex.
Yeah.
Yeah, on there. Hey, Joe. Good to see you. Joe Paxton.
So how do y'all want to stand at a podium, or do y'all want to walk? Or okay, so I got a little introduction, welcome, and then I got little bios on all y'all. I'll just talk through all of them, and then we'll start with John.
Any softball questions you got?
Yeah, we need to have lots of questions.
So, Greg, I have a problem. I'm a scientist and engineer. I'm likely to stare at the features of my shoelaces.
There you go.
Just make sure not.
Oh, you're out.
To make sure you don't wind the wire so tight that you can't sit down and stand up. Okay, you gave them a great question.
No, I told him to say
Bonus points.
doesn't bring it.
Wow.
I would rather have either or there's
But this is great. You didn't even have to offer free food. Oh, I'm on.
Test.
So a few of us have had hot mics trying to put this thing on.
Are we in some order?
I think you're first. I don't know. No, I mean, can I sit here?
Yeah,
Okay.
you can sit on the end.
I just, this cold, I want to sort of, if I have to cough, I want to turn this way and cough, and not have to cough on somebody.
Great, thank you.
Huh?
And everybody quieted down at 1 o'clock, just like they're supposed to. All right, welcome to the Advanced Manufacturing Summit. Thank you for coming. Today I'm really excited to have 4 experts who are going to give us their perspective on the future of manufacturing in this country. And the Interdisciplinary Center for Advanced Manufacturing Systems is pleased to present this event with the Samuel Ginn College of Engineering to start a discussion on the need for robust manufacturing industry in the United States. Let me also invite you, while I've got your attention, to our grand opening and open house tomorrow at 1:30 at the ICAMS facility at 1490 Pumphrey. If you have an opportunity to come by, we'd love to have you come visit. So today we have 4 people here that are going to give us somewhat varying perspectives on future manufacturing. We're going to start with John Vickers, who currently serves as a principal technologist for the Space Technology Mission Directorate at NASA headquarters, and in the senior leader position for advanced and in-space manufacturing at Marshall Space Flight Center. He's a member of the National Science and Technology Council Subcommittee on Advanced Manufacturing. Then next we'll have Adele Radcliffe, who is Director of the Innovation, Capability, and Modernization Office. In this position, she implements the broad authorities of the Industrial Base Analysis and Sustainment Program, which happens to be the benefactor that supports ICAMS here. We're very glad to have her here. The program is to strengthen the competitive posture of the United States Defense Industrial Base by fortifying traditional technical capabilities and forging emerging industrial sectors to respond to at will to national security requirements. Then Nathan Edwards is the Executive Director for the U.S. Partnership for Assured Electronics, where he is responsible for growing the collaboration between the DoD, electronics industry, and academia to help ensure U.S. government has the access to trusted and secure and resilient electronic supply chains. He spent the last 17 years focused on security of manufacturing supply chains for critical electronics and defense systems. And then we'll wrap up with Chris Peters, who is the CEO of the Lucrum Group. He has extensive background in driving innovation and adoption of manufacturing supply chain solutions. He was co-founder of MetalSite, the world's first industry-backed manufacturing supply chain hub, funded by 5 of the country's largest metal producers. Chris has done similar work in 20 other industries, and his work has been documented in several books and publications ranging from the Wall Street Journal to Business Week and Industry Week. And he's also been leading our technology adoption with small and medium manufacturers effort at ICAMS. So with that, I will turn it over to John to start us off.
Okay, thank you. Dr. Harris, Dr. Harris had, is that better? He had asked us. First, let me say I'm really excited to be here. If I don't look excited, I caught a cold on an airplane yesterday, and so I'm a little bit hyped up on cold medicine for my talk. I think I had a chart that was before this chart, or is this the order that they're in? So I am really excited to be here. I'm sort of the advanced manufacturing person for NASA, especially for the technology portfolio, and so that gives me responsibilities NASA-wide. So I get to work with all NASA centers, all of our personnel that are in the materials and manufacturing area. So at NASA, that might be, it's probably about 800 or 900 people, and so that's part of what you guys can go on to the next slide, and I'll get to it in just a minute. But Dr. Harris asked the four of us to talk about what we see as the future of manufacturing in the United States. So how is the United States going to be competitive in manufacturing in the future? That's a big question. For us my colleagues are really smart. I'm sure they've got some smart answers, but that's a big question. And predictions about the future are really hard. So I thought about it while I was flying around last week, and how could I address that? And so I've just got a couple of slides, and I'm going to try to be really brief in my remarks, except that I tend to go on a little bit, and so I may just stop abruptly if I've gone on too long, or if somebody thinks I've gone on too long. I've used this chart before, and so I pulled it up. You know, there's a lot of us, especially Adele and I go back a long way, that participate at the federal government level and work and think about what the future is in these critical technology areas, and advanced manufacturing for us is certainly one of those. And so these documents that you can go find, these are all very new, maybe a year old or something like that. You can go see what we've said collectively are the important things for us to consider. The biggest one, document on the screen there, is the National Strategy for Advanced Manufacturing. So I don't have to answer this question for Greg. I mean, we've tried to put that together, and in that document we've focused on three areas: technology and workforce and the supply chain. And so I think that's probably it. Those are the main, if you're talking about advanced manufacturing, those are the main elements that we need to focus on. Now, there's some things within those elements that we'll probably be successful at from a technology perspective. And so that, for me, I'm the principal technologist for advanced manufacturing. So that's what I do. For NASA's missions, it's my job to help us have those technologies available for us to do those. And they're pretty super missions. The missions we do at NASA are pretty cool missions. And the technologies in advanced manufacturing contributes and really is foundational to those missions when you think about it. The mirrors for the James Webb Space Telescope are made from beryllium and plated with gold. Those are manufacturing processes. And they're thermal-dimensionally stable, to nanometers, and that's some pretty cool advanced manufacturing stuff. But but I put a number of these documents in this slide because if you look across them, you'll find some commonalities. From the technology perspective, I think that's the real. For me, that's the real. So how are we going to be successful in the future in advanced manufacturing in this country? The adoption of technology is going to progress. How, as a country, are we going to adopt and adapt to that technology? We've got some big, so there's some really advanced technologies that are going to affect advanced manufacturing. 3D printing, artificial intelligence, robotics. Is everything going to be AI-driven, robotic, 3D printed? Well, not for a while, but those are the trends. Those are the directions that we're headed in. And so, how can we adopt that? We had a little tour earlier of the additive manufacturing lab. We're doing those guys. I say we because we're doing it too. We're helping to sponsor some of that work. We're doing computational approaches to understand the additive manufacturing processes, so that we can do those much faster, so that we can utilize them much faster and much cheaper. If we do everything empirically, it's going to take too long, and it's going to cost too much for us to adopt those technologies that I'm talking about. And so digital is a big piece of that technology, and how we can, adopt and adapt to that faster as a country is going to be really important. Dr. Harris and I collaborate some, and so I wrote an article a couple of years ago, and I was talking about the digital transformation, and as it applied to advanced manufacturing, there's about, my colleagues know these numbers better than me, there's about 300,000 manufacturing factories, companies in this country. And so the opinions differ on how aggressively, how capable those factories and companies are for digital transformation adoption. And so I was hearing numbers 30 to 50%, are, in this, becoming available to adopt these technologies. And so I didn't believe that really. So I asked Greg, did he have data? Could he give me a number for this article? He believed it was more like 10%. That's not very good. We've got to find, that's one of those barriers that I talked. We've got to find a way for those companies and those factories to more quickly adopt and adapt to these new technologies. And so I think for me, that's the answer to the future of being manufacturing competitiveness and us being successful. If you look at these documents, you'll see those same kinds of and just look at the technologies. You'll see those same kinds of technologies sort of rising to the top. So I don't have to tell you. I think it's apparent what those technologies are. By the way, Auburn's working on all those things and doing a heck of a good job, because I get to see what's going on around the country and around the world, not just at universities, but in government agencies and in industry as well. And there's these areas like Dr. Harris's ICAM Center, the NCAM Center for Additive, are globally leading activities in these areas. What else about these charts? There's a National Space Council space manufacturing. So I do space manufacturing technology, but that's some pretty high-tech stuff. And so it sort of, for me, helps to encompass some of these more industry general technologies. What have I got in the next chart? Because I'll do this all day long. So go ahead and play the video, and then I'll talk. It's only a minute, then I'll talk after the video.
Now 56 past, I wasn't prepared to translate that as I was doing that little tease.
Oh, that's
that little
right.
mark with the A and then the ring around it.
At?
See, that's what I said. Katie said she thought it was about,
Yeah. Oh.
but I'd never heard it.
Around
I'd never
or
heard it
about.
said. I'd always
That's
seen the
around.
mark, but never heard
Yeah.
it said. And then it sounded stupid when I said it. Violence at NBC.
Yeah, I heard around or about up in the lunchroom the other
See,
week.
there it is. Violence at NBC. GE.com. I mean,
Well, Allison should know.
what
do you
is
say to that,
internet
Allison?
anyway?
Internet is that
Massive computer
right,
network.
the one that's becoming really big now.
What do you mean? That's big. How does one? What do you write to it like mail?
No, a lot of people use it and communicate. I guess they can communicate with NBC writers and producers. Allison, can you explain what internet is?
No, she can't say anything in 10 seconds or less.
Oh, Allison will be in the studio shortly.
What is
What
it?
does it mean?
It's a giant computer network made up of started from.
Oh, I thought you were going to tell us what this was.
It's like
You've
a
been looking in the
computer
dictionary.
billboard.
It's not an. It's a computer billboard, but it's
Right.
nationwide, and it's several universities and everything all joined together.
Right.
And others can access it.
Right.
And it's getting bigger and bigger all the time.
It
Just
came
great.
in really handy during the quake. A lot of people, that's how they were communicating out to tell family and loved ones they were okay because all the phone lines were down.
I was telling Katie.
So
the
you
other
But
day-
you don't need
can
that-
stop.
you
It's
don't need the
almost
phone lines
almost
operating?
finished.
No.
So that's 1994, and if you see the little graphic to the left, that's the original DARPA-funded project that started the internet in 1969. So you go from 1969, and really think about what those guys were thinking. So we're talking about technology and what's it going to be in the future. Think about what those guys were thinking in 1969 with this ARPANET. It's just something that was utilitarian, probably, right? So that they could talk to, it's 3 or 4 university nodes, and so that they could talk to their colleagues at other universities. Could not have imagined. I mean, really could not have a mat. And then so fast forward to 1994, these guys, they don't even, it's so funny. They don't even know what the internet is. Now look at us today. I mean, something that's made the biggest impact on all of our lives, right? I mean, name something else, that's made such a big impact. But my point about all that is technology is sort of funny. It's hard to, and it seems like that happened in an instant. And that's the thing. There's this book by Thomas Kuhn about how he talks about scientific revolutions and how they don't come along by incremental advances. They come along through paradigm shifts and dramatic. This is a dramatic paradigm shift. The internet is. These other technologies are the same way. It sort of creeps up on you. But in technological terms, this is what happened to the internet is an instant, really. It happened very fast, but we didn't realize it. Now all my grandchildren, my 4th grade grandchild has a cell phone kind of thing. We didn't we sort of went to sleep and woke up and we're all in this digital world. That's the way technology is. And so I don't know what, it probably is AI, it probably is robotics, it probably is 3D printing, but it's hard for me to know. If I did know, I'd make a lot of money because I did know. But anyway, that's sort of my story for what's going to make us successful in manufacturing in the future, at least part of the story. So thank y'all.
Check. Check. Is it on?
Yes.
It is? Okay. So it's interesting. I felt like I was watching an episode of Seinfeld, which I know precedes, and even that speaks volumes to really the question on the table. I mean, did you say that was 1969, the drawing was from DARPA? So really technology doesn't happen like that. It's long enduring development, and then the conditions are right, then suddenly it becomes a paradigm shift. So I think if, to answer the question on the table, which where do we think manufacturing is going to be in the future? I don't know. I think I hope it remains in a state of unfinished business in this country. That's what I hope. What do I mean by that? I don't have nice video. I graduated. What's funny about the video that he showed was 1994. I graduated from Mississippi State in engineering in 1988. When I came in to the engineering program, we were just phasing out slide rules, which I saw as a ginormous one. It's an artifact, right? It's considered a museum legacy item. Well, some of us are still around from those museum legacy days, right? So, and I was taking my first programming class was on Fortran on Key Punch. I was more focused on the cards and understanding where the hole needed to go than the purpose of what I was trying to do on my programming. And for anybody who lived through that, it was a nightmare if you dropped your cards, right? They're scrambling all over the place and keeping the rubber band industry alive because you're walking around with your pack of cards. That preceded, that was just years before the internet came into play. So we're living, right? We're living the evolution of where we are on technology every day in terms of how far we go and how fast we go, but how long it takes to actually see mature technology go from idea to a paradigm shift in culture. When it comes to U.S. manufacturing, we're kind of in a Benjamin Buttons moment, right? The heat map that I have here is capturing where we currently are on two things. For decades, we held we were the global leadership of manufacturing. Everybody, how many of you grew up around a manufacturing plant of some type, textiles, whatever it was, right? See, nobody, few of us, right? That's how far we've come in just a few decades, right? We've gone from being a world leader into it to offshoring everything, all for efficiency and for research premier. We wanted to be prestigious researchers in this country. We abandoned manufacturing for a number of reasons. There's business and finance folks here. You played an important role in that. Are you here?
Are you going to admit it?
Yeah, how we valued manufacturing in this country in the terms of its role, in terms of the bottom line and stock values and other things, forced manufacturing offshore for a number of reasons, right? And I think COVID highlighted what many of us who had been in this space for a long time were arguing that that was a critical flaw in our thinking, that we could maintain our prestigious, innovative mindset here and allow things to be made somewhere else. And we've spent decades now. We started early 2000s on writing advanced manufacturing reports at the federal level of what we needed to do to reclaim manufacturing in this country. It was 2011 that we established a flag, planted a flag called the USA Manufacturing Institute Network now, and that's what that's called, that we decided that that little square inch of property that people could agree on, that we could maybe have a chance at doing something in manufacturing. That was it. Was advanced manufacturing that couldn't be realized for a decade or more is what people said, well, you might have a chance of doing that. So we planted our flag there. And then we've been backing our way into what you see today. You know, we're restoring foundational capabilities and capacities that we've long moved offshore. For all the discussion about advanced manufacturing, we import, I don't know how much we import. I haven't done the data on the quantity, but I know one company imports 100 million pounds of cast iron every year. Think about that. Why? Because we don't have the casting houses that make it big enough or can turn over that type volume every year. And so, you know, I think that, and then you overlay now what we're trying to do in regrowing microelectronics in this country through the CHIPS Act, restoring foundational industrial capabilities and capacities that are needed to drive everything that we do in society right now, microelectronics. Right? So to me, you've got, and you need them both. You've got to have both the strong castings and forgings capability where we've been doing, as my metallurgist friends like to say, thousands of years, and we still don't know everything about how to do that. At the same time that we need to be able to have these clean facilities to produce some of the most sophisticated microelectronics that we use on some of the most things that you can't afford a failure on, whether it's a submarine that goes underwater to depths that you can't even imagine. That unfortunately we've had a reminder of the austere conditions that we face for national security that we send men and women on every day. The depths that those systems have to withstand, and the material properties and the rigor, the thermo cycles that they go in and out through for months at a time. And these two conditions have to coexist in our industrial base. But where we have been spending, first starting with what's our strategy going to be, and then resourcing against that strategy. And hope many of you are following that. If you're in this room, you should be, your business, when you graduate, is going to be understanding where the market's going. And your U.S. government is spending a lot of money to restore U.S. market capability here, and that's a lot of money that is being invested in the industrial base. And we're doing it along the lines of CHIPS Act, that I won't steal the thunder of these two guys. We're restoring capabilities along castings and forgings lines in this country, investing in suppliers. We're rebuilding infrastructure that's needed on, we all were talking earlier about the shortage of NDT, non-destruct testing capabilities in this country, right? The basic infrastructure that's needed to be able to test all of your new manufacturing capabilities and assess whether that additive part is going to be a spec part, right, for use, whether you're sending it up in space or down underneath the waters, right? We're rebuilding that infrastructure. We're working on advanced materials for some, I'm from the Department of Defense, so my focus is on national security. So things that go high, fast, and far. High temperature materials. We're focused on building capacity here and here for those type applications that support us for national security, as well as then what we want to do on space exploration and other things. And then we're focused on workforce. And all that you do is built on who you are. So we're focused on technology, right? But it's all about the people. I'll say that's one thing that Auburn and Alabama is getting right. We had a National Academy study just a few months ago rolled out in December that one of the recommendations was that my hypothesis is that our engineering programs at the undergraduate level need to be focused on how do you make stuff? Really, how do you make it? Because at the end of the day, our business is to convert your research into product that can be commercialized to contribute to help society. And if it stays warehoused in the research labs of a university system for prestigious purposes, why did we spend that money? And so our engineering program should be really focused on how to be scaling that technology coming out to the good of society for national and economic security. And the National Academy studied a number of universities that had this more of applied mindset. And we pointed to what's happening here at Auburn. Not only what you're doing here in iCamps, but the relationship you're creating with the community colleges, with the folks that stand on the shop floor. Why is that important to that heat map and what we face today? Everything that you do is related to that heat map. If you're sitting in it's only coincidental that these are Auburn's colors. I'll just say that. If you're in orange, these are declining populations. If you're in blue, these are rising populations. If you're in blue, your rising population is due to migration out of the orange zones, most likely. We are a country that is declining in population. That means we're going to need more out of technology to remain competitive in the world. If you were to take now the manufacturing skill sets in society that overlay this population, it is the inverse. In the Northeast, as an example, where we have declining populations, we have strong remnant advanced manufacturing skills, and we have rising, surging requirements for producing those capabilities, right? The need to have strong manufacturing skills. We don't have people there. And so we're recruiting tens of thousands of people in an area that has, that is dying populations. In that blue corridor, it's just the opposite. You got a lot of people hitting there, large manufacturing, but we don't have enough skill sets needed to be able to satisfy those. So whichever condition you live in, it still boils down to not enough skilled workforce. And so for us as a society to continue on our evolution of manufacturing, we're going to have to educate everybody as much as we can, whether it's the engineers or at the technician levels in this country, to be able to continue to reap the dividends of all the outstanding work that's being done at the Auburns and the Mississippi States and the Texas A&Ms and the University of Tennessee's, which by coincidentally are SEC programs, land-grant universities. I'll just give a plug there for the leadership of the SEC on that front. So I'd say that in conclusion, for our opening remarks that we've made a good start over the past 15 years to restore manufacturing here in this country. We've made a good down payment on it. And certainly the environment that we face in the news every day, with whether it's Ukraine or Israel or Taiwan and what they face, remind us of why we need to work faster at restoring a manufacturing prowess in this country with strong engineering capabilities coming out of universities like this that know how to make things, lots and lots and lots of things. And I think we hope that our path is one that we continue to grow and our business remains unfinished. That's what I hope, is that we never lose sight of the lessons that we've learned over the past decades of what it meant when we abandoned manufacturing. So I hope that what I hope is that you guys are up here 10 years from now talking the same thing to the next generation, and we see more manufacturing plants around here, more technology being adopted by the small and medium manufacturers. But I'd say there's a big question there, and that is for us, your generation, really to help solve. But I'm hopeful. I'm hopeful of our unfinished, continuing business of manufacturing.
Am I live? Can you hear me? All right, very good. So I'll get to talk about electronics. I love electronics. There's always a story. We talked at lunchtime about cautions of stories, but I'll start with this quick one. My first programming language was Fortran. It was in the mid-90s, but I got to use a 1200 baud modem dialing into a VAX account in a remote place like Alaska. So the speed of tech adoption, even then, spanning 1 decade or less, was phenomenal. Back then, I was studying theoretical physics and mechanical engineering. I went off to do something a little more practical with thermodynamics and emergency operations. But when I decided to go back to school, in just that 9.5-year span gap I had, it was very clear that the electronics were controlling everything in society that we were doing. And I don't think that story has changed. So I'm going to talk a little bit about electronics manufacturing. I think, though, you will hear some common themes from what all of my colleagues talked about. So let's go to the next slide. Just a little bit about our organization, the U.S. Partnership for Assured Electronics. We're focused on the defense sector as an industry consortium. We help those conversations between Department of Defense agencies. We work very closely with Adele's office and bridging the gaps between what industry, what language they speak, what Department of Defense speaks, some of the issues and challenges that transcend both of those, and really try to converge on some of those problems. But you can see a lot of our members in the consortium really span the whole ecosystem of electronics. Those in research, in academia, those who design, build, manufacture all kinds of things, including workforce is a very important topic as well. Let's go to the next slide. So what does the future of manufacturing look like? Here's another story that goes with this. I get to mentor a lot of middle school, high school students in where I live in Colorado. And some of the young students are introduced to CAD or graphic design with Blender. You can use animations with Blender and so forth. And they just want to print something. Our local library system, which is great, they have a little wood CNC mill, they have a laser cutter, carbon dioxide laser, they have a lot of the FDM printers and so forth. And again, they like this easy button. And so if we think about electronics, it's a little more complex than that, but I think the same goal in mind is we want the ability to design and compose new combinations of technology and manufacture it quickly. We want to be able to adapt to society changes rapidly. And so that's why I kind of like this big easy button, the green button. And so we'll kind of identify a couple things that is happening this year. We'll see that introduced into manufacturing very quickly. But then there's also some future outlook things that you all probably are either aware or need to consider in how things are changing. So next slide. So in the electronics manufacturing, for years and years, it's always been more of a two-dimensional planar surface in manufacturing. We have circuit boards. We laminate the layers together. We have conductive pathways. Even that whole lamination process has evolved very rapidly. Now we're using flexible polyamide with other conductive materials and conductive inks even. Got to visit one of the lab tours here where they're using nanoparticles and laser methods to deposit and create those pathways. It's phenomenal, right? But the circuit boards, has been kind of a connection. We've put chips, components, passives, other things on there. We mechanically adhere them together with solder and some epoxies. We have to think about that thermal problem because when you heat these things up or put them in a vibration environment, they tend to shake, rattle, roll, and break off. So there's some considerations there with the two-dimensional space. The middle picture, though, captures where things have gone in the last 10 years. We're trying to put things, more components, more submodules, sometimes off-the-shelf modules, and integrate them together. So you get these three-dimensional form factors where you're putting board on board, again, some fancy epoxies and methods of assembly so you get a repeatable process. We also see the thermal problems show up. These are those heat sinks, the silver heat sinks there, which is really interesting where that's gone today. The next stage really is what else? Well, I'll say with the what else is answering this SWaP-C problem: size, weight, power, and cost. And most of us in our pockets, we carry a supercomputer called a cell phone. I remember when the first cell phone or smartphone, we'll say, was introduced when I went back to college. Was phenomenal. But how you manufacture that, actually, we don't have a capability in the United States to manufacture our current cell phones or some of the high-density modular devices that we're using in electronics, which, again, controls most of the things we use in society. So we have to think very creatively about how to build those, everything from the materials, the chemistry. Back to that thermal problem again. And I spent time in the thermodynamics as a firefighter, but things burn up quickly, and so how you get that heat out. When we fly things to space, you have a thermal problem. Actually, it's a dual problem, right? We have to heat the batteries so that the batteries last, but then we have to cool the electronics that are operating, and so there's a challenge there. But again, what does it look like for manufacturing? So let's talk a little bit about that in the near term. Next slide. All right. So today, we have a lot of these Lego pieces out there. We can go and shop and find components. We can get these from our favorite brokers and suppliers. Some of those we build in the United States. Some we don't. Actually, many of them we don't. And that's a real challenge. At some point, we are going to have what we have. And that's kind of the Department of Defense question, is if we get into a challenge on a global front with our supply chains, how do we keep building? So if you think about these Lego blocks, whether it's a module, a semiconductor, a chip, something else, we have all these ideas and concepts there. We have all these designs in the open source community. I know open source kind of came from the software domain, but open source hardware community is phenomenal. So there's an organization that colleagues of mine, they run it. They're building and running challenges for creating the designs within semiconductors. So there's this whole library of creative designs in a very rapid fashion. They'll do a challenge for 2 weeks, 3 weeks. That's it. It's an open community. That community has also evolved to allow global contributors who wouldn't normally be part of the semiconductor design. There's courses online, videos you can learn about this. And these are folks that have not gone through a formal education process. They're learning things on the fly and doing it quickly. So we have design libraries now from a broad community. We have components. And so the next stage really that we want to get to in this is this rapid integration idea. How do we put it all together? How do we reconfigure our former design and build something new tomorrow? We're not going to take a year to do that. Those who've worked in the semiconductor area know that you have to get your design, and then you'll schedule your tape out. That's when you actually send it to the fab, right? And that tends to be 1 to 2 years out before you might get parts back. A terrible time scale, right? We need to move faster. And so we're at this place in time where we talk about heterogeneous integration, putting chiplets on these substrates together, interesting materials, and doing it at a very rapid scale. But it's all very, very small. Inside of our modern iPhones, for example, inside one of those system and packages that Apple is using, there's about 245 components all built into what looks like a single chip. And that's changed. I think every quarter they introduce a new tech node in cell phones. It's phenomenal. So we're shrinking things. We're having to figure out new adhesives, new processes to get these in the automation. So next slide. And so some of the key enablers really, I threw up a few things there. This isn't all of it, but materials and tools. As a scientist and engineer, I like that space. That's my happy place to be. What kinds of new tools do you need to make things happen quickly and smaller in a variety of ways? The conductive materials, that's the ink, you might say. Although we talked about inks in our tours today, there's some boundaries there. But that conductive media is really an enabler for electronics. But there's new materials that have to go into that. Data automation, I think you all are probably seeing this up front and center. We talk about this with Industry 4.0, full automation end-to-end in manufacturing. But it's a very data-rich environment. Every step in a manufacturing process, we have test data, recipe data, sometimes stages and steps along the way data that we can get out of that. So how does that help us with early detection and flaws and corrective actions in the manufacturing line? That's an exciting place to be. It also generates a lot of data. If you talk to folks that are, again, in the semiconductor industry, their processes that they use, which is still highly automated, terabytes of data for a single run. It's a huge amount. So we have to have some advanced computational perspectives added to this to help us in that manufacturing. The last thing really on this slide is the rapid reconfiguration. Thinking about not just the types of pieces you want to put together, but how you put them together and the dimensional space, 3 dimensions, or sometimes 2.5 dimensions. We use that in some of the semiconductor areas. The colors represent different feature sets, perhaps, even though the pieces fit together. What colors do you want? And so doing this, again, in a very rapid way is important. At the very bottom, I'm not going to talk too much about this because Chris will talk more. This is the business-to-business adoption. I had a conversation just yesterday up in Huntsville. I was at an IEEE conference up there talking with a colleague, and he said, for his end of the business, which is integrating chips into packages, advanced packaging, they have a challenge in industry. One company who produces semiconductors will not collaborate with another company who produces, and vice versa. And so how do you get integrated test data to make sure you're assembling right? How about your predictive failure modes when you put all these mixed systems together? They don't want to talk. So business to business really is a challenge. It's not a technical challenge per se, like in the science and engineering world, but it's a major blockade to progression in the advanced manufacturing. Next slide. So let me share some things that are right around the corner. This picture I borrowed from a company. I'll get to talk with them next week. They're up in New York. They have I'll say business proposal. I'm not sure where they're at in the stage of things, but what they propose is to reduce the size of producing electronics, the facility it is, about 5 times less, 10 times faster, 5 times less money to build new semiconductors. They have new materials, gallium oxide kind of process where they can have a immediate flaw detection and repair in that. Now, those who are familiar with the semiconductor, and I haven't seen the little fab that you have here on campus, but we know that the wafers, silicon wafer, inherently they have little cracks, microfractures, or other flaws and impurities in that. And so when you build your transistors on top of that, those flaws really are propagated throughout your process, and you have to throw away those sections of the chips. With what they propose is to have a high yield. They can change it very quickly and on the fly in the manufacturing process. They also propose that they're a high mix environment. If you go to a chip producer like TSMC, which is the number 1 global producer, we're glad they're building a foundry in Phoenix, Arizona, on a 1,200-acre plot of land they bought from the state of Arizona. That's exciting. A lot of challenges they have in the construction of it. But when you engage with them, again, you're 3 years out before you get chips back, maybe longer. And they only want to do business with you if you have more than 1 million parts you want to produce. It's a high volume. But our needs in society are changing. We need high mix. We need to change it tomorrow, change our designs, change our potential process. We want to put a special chemistry in there to give it enhancements that give us special RF communication abilities or something else. So we're seeing this. Now, they also propose something that leverages the heavy data-rich environment and artificial intelligence. Now, that's a nebulous term in itself, but it's exciting to see. Let's go to the next slide. Another area that's exciting, this is in the interconnect domain and the materials deposition. And so, again, some of the research here in Auburn is already doing this with other advanced materials, but this is a production system where they, in the data-rich environment, they compare your design files and the computer-aided manufacturing files, the CAM, to what's being produced in real time. And so if your process has some flaws, and we always have tolerance issues, and especially when you're etching materials or milling or subtracting or even some semi-additive processes, there's always going to be an issue along the way. And so this commercial machine that they have from KLA is advertising the ability to compare what you sent it for manufacturing, and then if there is a flaw, it will use some optical laser technologies to either remove materials and shape in a three-dimensional space. Not so much they're showing rectangular wire traces, but three-dimensionally shape those or add new materials. And it's an exciting place to be. We didn't have this 5 years ago, by the way. This is, again, creating a rapid manufacturing capability that I think will enable all of us in society to do things in a very, very new way. So, next slide. So what is AI, right? I think this crosses all fields of engineering and science. It crosses into the computer science domain, really society as a whole. Let me back up a little bit. So I spent some time at the Department of Energy at San Diego National Laboratory. So when you think about supercomputers, you go down the road to Oak Ridge National Laboratory, who owns the U.S. government's responsibility for supercomputing power. You know, they've been working on algorithms and computational elements for a long time. And so the idea of machine learning is not really new, but as from a applied mathematics standpoint, the newness is how we're using it in society. So last fall, ChatGPT was introduced to the world. How quickly did it take for society to adopt that? Within months, we saw platforms like travel. We saw Microsoft adopt this into their own ecosystem. We saw other venues and other adoptions of this ChatGPT idea, which is you enter some texts and it searches the global web and gives you some information back. My son, who's in high school, he said, "Hey, can I try this out?" Now, working in national security, I always get concerned about, well, what are you asking? And where does the source information come from? He's building his own smart glasses, and then it's been a fun project. But he said, "Well, I just want to see if it can write the code for me." And he had to train the model a little bit, but after several iterations, it wrote the embedded software code that goes into his automotive grade processor for a single feature. It was phenomenal just to kind of see as a lightweight experiment. But there's some challenges here with that. So AI, what is it? Is machine learning from a mathematical standpoint? I think so. Is it generative automation? Of course, we hear generative AI more frequently these days, but yes, it's also enabling automation too. What about optimization? Absolutely. So all these things fit the picture for what AI is. If we go to the next slide, but there's some cautions, of course, with AI. Those of you who grew up with comics, Spy versus Spy, it's got a lot of history in our country coming out of Cold War era, and even today we all find a little humor in this. But the reality is, when we get to manufacturing, how you deal with independent test and verification becomes new. You can't necessarily use the same AI algorithm family to test something that you built with that same algorithm. It's no longer independent. So how do we know what we're building is what we want and what we specified? And so now we're having to lean on our mathematician friends to help us out. You'll see out there neural networks. Well, what flavor of neural network is it? Is it ANN, CNN, and a whole family of things, right? Is that it? And the cautions really, I think, for us in the engineering and science areas, we no longer have the visibility of the decision-making process that AI offers us from the rapid capabilities. And so we have to be mindful of when we use it and how we use it. And when we do this in electronics manufacturing, we're already seeing this in the optical inspection area. So when you produce a circuit assembly with automation equipment and reflow processes, it goes under this camera system, and there's a little bit of research area, how you deal with a planar focus on cameras and how you get that three-dimensional aspect. But that optical recognition of features or flaws and detections in the assembly from the metallurgic standpoint, we're using that already in industry. It's an exciting time. But again, how can we use this to our benefit to help enable the rapid reconfigurations that we need for society? Next slide. So this is one of my last topics really is on workforce. It's a passion area for me. I help with some of our local school districts, mentor robotics teams. The future of our workforce is something very different than it has been. And what I've seen even in my career, too, it's evolved very, very different than I thought it would be. And so what does that look like for electronics? And you could probably say the same for any of the engineering and manufacturing fields. We need folks who are informed on complex control systems. It's not a PID control, where you have your control theory and some calculus and a differential equation there, right? It is much more complex than that. These control plants for these advanced processes have to accommodate many, many, many other things, especially in this data-rich environment. So being aware of that. The materials, the metamaterials, the mixes of new compositions becomes very important also. So even being aware at engineering and scientist level, all the way down to a technician and operator level, we have to be aware of that. The other thing that's changing is in the automation. There's a lot of processes that are manual and still are manual. You go to some of the circuit board manufacturer facilities and they have some automation on a particular part of that line, and then they will hand cart these boards over to another part of their process. And so we have to figure out how to engineer ways to automate that so we get quick turns on the products. And some are doing a great job of this. But for the workforce, again, think about everything that can be automated in a repeatable way that enables us to produce new products faster. And of course, differently with all the materials. And the last thing I'll say about workforce really is, where's our talent coming from? I think Auburn does a phenomenal job of filling the talent pipeline and training folks for the real world. And that's amazing to see, but this is an exception. When I travel the United States, I talk with different universities, I talk with different companies, and they all have the same challenge of finding enough people that are interested in their industry. And this is, again, for the technical trades, all the way up through the scientist and engineer level. There just simply is not enough in our country that are interested. This is where I'm passionate about the K through 12, we'll say more of the middle school to high school level. Some of the success stories I hear are much like what you see here in Auburn, is the experiential learning, getting your hands on things to try them out, whether you're soldering something under a microscope or going to the machine shop to use your latest CAM tools and lathes, or building the Lego cars in the production line, right? Those are great experiences in learning. We all need to kind of own this problem set and consider that outreach to train up the next generation, get them inspired even to be interested in what we do from careers. So next slide is my final one. And so I'll close with these few thoughts really, with the new materials that we're inventing and how we put them together, the Automation Extreme AE. We can have all kinds of acronyms, I'm sure, and then how we're building things, new geometries, these new processes and materials, adhesives, is creating opportunities to put things where we haven't done that. Injection molded electronics is kind of a fascinating one. They're using the automotive and aerospace industry for some haptic feedback, but it's built into the plastics. And then also, don't forget the business to business. And the final thing, really, this quote, I love this quote. So Booker T. Washington, as I was telling our colleagues here, he's one of my new favorites for American heroes, right? And so he was giving this speech in Brooklyn, New York in the late 1800s there. That speech has been called Democracy in Education. Now, the problem for his day really was post-Civil War time. how are we going to bring education to all those who came out of slavery? And he really used that term, the weakest link. What is the weakest link really affects all of us in society. Today, it's a little bit different in education, but also you could replace education with any of your technical topics as well. We really have to think very differently about how we're doing business to meet the needs of conditions. Our conditions in the United States in manufacturing are very different. The needs are growing more rapidly. Unfortunately, much of society is unaware of that. But I will tell you, for example, we import about $2 trillion worth of goods from China. Our dependency on China is huge. Why can't we produce these things in the United States? We should, and we can, I think, in many cases. But again, the needs of conditions is we have to think about workforce. We have to think of the technology, the rapid integration, how we assemble things in an automated way, and then, of course, how we're testing things. So thank you for your time.
All right, so I'm going to stand and move. And of course, everybody's leaving now. Just getting started. All right, this also helps keep the photographer on his toes. It's a little bit easier when we're sitting there, huh? So listen, quick question. How many of you are engineers or are studying to be engineers? Yeah, so most of you. I am not. I'm a business person, I'm an entrepreneur, but I'm not an engineer, so I'm not going to talk in engineering terms, I'm going to talk in business terms. How many of you hope that someday the things that you're going to design and build will be used by somebody else, or better yet, sold to somebody else? Good, okay.
Every hand should be raised. We talked about this earlier.
I know.
You need to monetize the research here.
Hopefully everything that you're going to do is going to be used by somebody else. So I'm going to talk to you about adoption. I'm going to talk to you about the process that you go through to do this. So I'm actually on the program with Dr. Harris. We've been working on this 5-year longitudinal study looking at how is smart manufacturing being adopted throughout the U.S. industry. Ashley Yarbrough, who some of you know, she is the lead on this. I'm supporting it, and Dr. Harris is overseeing the whole thing. So how many of you are familiar with the technology adoption life cycle? Innovators, early adopters, early majority, late majority, laggards. Yeah, most of you? All right, next slide. This is where it all started. Dr. Everett Rogers out of the University of New Mexico, his first version of this book, which is my favorite business book, was published in '63. This is version 5. I actually have 2 or 3 different versions because it is so helpful in understanding how do you drive adoption? How do you accelerate the depth and breadth of adoption of an innovation? Everything else that comes after it that talks about that technology adoption life cycle, whether it's Geoffrey Moore and Crossing the Chasm or any of those other books, they all go back to this. So start at the source. This is a great book for you to read if you're concerned about how can the things that you design and build be more quickly adopted by others. So I'm going to go through and I'm going to give you a brief overview of adoption. I'm going to talk about the ICAM's study, what we've been learning, and what it means for us. And then I'm going to talk about why this is important to us as a country, to the U.S. manufacturing industry, why we should be paying more attention to this. So the 5 stages of adoption, according to Dr. Rogers: knowledge, persuasion, decision, implementation, confirmation. Those are the 5 major stages. And so knowledge is your first awareness of an innovation. What is it? How does it work? Then your persuasion. Well, how did somebody I know benefit from it? You know, I'm talking to Adele. How did she get some advantage out of some innovation? And then how could it benefit me? The decision. How much is it going to cost? How much will it take to implement this? And then how widely is it going to be adopted? Is this something that if I go ahead and buy and implement, people are actually going to use? And then implementation. Okay, who's going to install it? Who's going to maintain it? And how will we drive adoption? Once we have it in there, how do we do that? And then confirmation. Ongoing support to make sure that people are continuing to use that. As you go through, as you jump into industry, one of the things you're going to hear a lot about change management. And when you're coming up with a new process, a new technology, and you're going to they're going to talk about change management and how you do that in an organization. Change management is different than adoption. In change management, in an organization, I have a carrot and stick, right? I have a carrot, hey, if you use this, it's going to help our organization do better, bigger bonus at the end of the year. But I also have a stick. You don't follow this process, you're going to be fired, demoted, moved to another department. Adoption is when you don't have that. So if I'm in one organization and I'm trying to get them to buy something, to use something, I don't have the stick. If I'm a buyer and they're a seller, or I'm a seller and they're a buyer, all I have are these things up here, the carrot, to get them to use, to adopt that innovation. So it's something important to think about. How can you move through those stages? That's a lot of what we did in this ICAM study and how we're looking at the adoption of 6 smart manufacturing technologies. And you're going to see those here on the next slide. This is coming out of this year's report. Now, the adoption stages on the left, we modified a little bit for this project. So we have learning, researching, deciding, implementing, and using. But here are the 6 technologies: 3D printing, AI, automation, big data, sensors and AT, and predictive analytics. So take a look at this. More adoption at the top, less adoption at the bottom. Take a look at the second column, AI, artificial intelligence. Everybody's still down here at the very early stages of this. Very little adoption. Very few are actually using it. So we're able to track where industry is through those 5 steps, and it's really interesting looking at this year over year. We can start to see how industry is moving through those different stages. But now look at automation. Automation, you've got very few down in the early stage because a lot of industry is using it. They get it, they understand it, they've seen the benefit, they've made the investment. So this gives us an overview of where industry is. On the next slide, what we're going to start to see is what are the barriers that keep companies from moving from one stage to the next. So if you look at artificial intelligence here, what we identified is awareness and business case. Some information, that's what's really lacking. That's the biggest barrier in the orange up there. That's what's keeping them from moving forward. And as we went out and looked at it, we look at industry publications like Modern Machine Shop, and we look at other things. And who is talking about AI in the context of manufacturing? So if I'm a machine shop, where am I learning about AI and how it can apply to my machine shop? There isn't a lot out there. And there isn't even a good solid definition of what is AI. So it's hard for those in industry to understand how it even applies to them. So as we look at this, we now start to be able to identify what are some of the things that we can put in place that if we had them available, they could accelerate the adoption of that technology. So in this case, what we need are materials to help educate the audience. And those materials need to be in the form that they use, so in the media that they read, whether that is traditional media like Modern Machine Shop, or it's in YouTube or Reddit, wherever it might be, and it needs to be in their vernacular so they understand it. All right, let's go to the next one, and now let's look at automation. Well, if you remember, automation is pretty far along, but there's still a lot of companies that aren't fully there yet. What's holding them back? And what we learned in that case, cost and workforce skill set are the biggest barriers to them adopting automation. So, again, if we put tools in place, if we provide a greater access to capital or subsidize some of the cost, that's going to help accelerate adoption. And on the workforce, if we had programs to help upskill existing workforce, that would help accelerate adoption. So what this program that we're doing under Dr. Harris is giving the government and academia levers. Here are levers that if you move these levers, we can accelerate the depth and breadth of adoption of these different technologies. So that's really important to understand. And as you go through your professional life and you're developing products, goods, solutions, keep this whole thing about adoption in mind because it's going to be really helpful in driving your success. if you invent something and nobody uses it, nobody adopts it, it is nothing more than an academic exercise. And in here, that probably sounds good, but out in industry, that's not so good. You're not going to get paid to make things that nobody uses. So next slide, please. So why is this important? The country that can best accelerate the depth and breadth of technology adoption is going to have a competitive advantage. And I'm going to give you an example on the next slide. If you take a look at what's going on in Korea, I use Korea as a model all the time. I was a guest of the government over there a while ago, and I had a chance to see firsthand a lot of what they're doing. Back in 2019, Korea set a goal. They wanted to have 30,000 companies at what they considered level 1 or level 2 adoption of smart manufacturing by 2022 and 7,500 at level 3. They blew that out of the water. I just talked to them this year. They far exceeded all their expectations because they did some things that were very smart. First of all, the government subsidized the cost of ERP systems. They would pay companies half the cost to go out and put in an ERP system with one condition. We want you to be willing to talk to others, your peers, your competitors, about the benefit you're getting by having this ERP system in place. And we want to have access to your data that we can aggregate and pull together. Very smart thinking, because now they've got those companies using this, and the number one driver of adoption is peer acceptance. So now if I'm talking to Adele and Nathan here, and I'm saying, hey, listen, I just put this in, here's what it's done for me in a business perspective, they're going to say, oh, okay, now I understand how that fits with my business. So that's one thing they did. But the other thing is these 19 demonstration centers. Around the country, they've got 19 centers where companies can go and learn about these things, see these things in operation, and actually visit with people who are using them in real time. Again, peer acceptance is the number one driver. So I go in and I'm talking to somebody else that looks like me, talks like me, and they're telling me the benefit, the value they're getting from this. That's going to resonate with me. That's going to help me get off the stick more quickly.
Hey, Chris.
Yes.
More than a round table.
Hey, this is
really,
jump in.
that's really important, because in another study that we did, looking at automation and technology adoption, the longer a company went without adopting technology, the less likely they were.
Yep.
There's this growing gap. It's a fear factor of that industry, sets in an industry where they're very unlikely to adopt it. Any technology at that point.
It's an excellent point. And it's one of the things that we've been learning in this study is that we in this country are behind a lot of other countries in the adoption of technology. Now, we're focusing on the 6 what we call smart manufacturing technologies, but there's an inherent fear, reluctance to do that anyways, unless there's some compelling reasons. But here's the thing about these demonstration centers. They have 19 across the country. The country is only as big as Indiana. It's not that big. But what they realized is that small to medium-sized manufacturers are not going to travel far to go learn about this. So if I have it within a 50-mile radius of where they are, I've got a much greater chance of pulling them in and letting them see this. We do not do that very well here in this country. We've got some big places. We've got Oak Ridge. We've got ICANNs now. We have some different places where companies can go. On the electronics side, it drives me nuts because we don't have anything in this country where an electronics manufacturer, PCB manufacturer, advanced packaging, can go to see these technologies in place. So we're talking a lot about the need to put those things in place, make them available.
Small and medium manufacturers do they have?
In Korea? I forget what the number is.
Less than 300,000?
Much less than 300,000.
So their percentage of adoption at the smalls is way greater than
Much greater than ours, yeah. So these are things to keep in mind as we go through, and especially as you're developing solutions, whether it's a product, a process in your manufacturing environment, think about it from the standpoint of adoption. Think about what you're going to do to help accelerate adoption of that innovation to make it more successful. I think that's the last slide. this was the last point here. The thing I love about what Korea is doing is they are using this as an economic development tool. The government of Korea is going out and marketing to the large multinational corporations saying, come in and use our suppliers. We've outfitted our suppliers with these technologies, these capabilities. They can make your products faster. They can make your products cheaper. And by the way, they know how to innovate better than any other manufacturers in other countries. It's a very powerful economic development tool. So I think that as we think about our country, we need to think about not just the technology, but how do we accelerate the adoption of that technology. Thank you.
Thanks, guys. That was awesome. We're going to open it up now to questions from the audience. Hell, you can handle this. If somebody has a question, take it. Okay. Of course.
Should I stay here for the question? Sure. So can you hear me? Yeah. Right. So you have stressed that it is important for the United States to have a robust manufacturing industry. But why is it important? Why can't the United States focus more on building a robust supply chain and have good trade deals and just buy things from other countries?
I'll take that. Or I'll start that. COVID. I think COVID, I hope COVID focused us as a general population on why it's important to be able to make things where you are, right? So you're not always guaranteed that even if you have agreeable resources, that you're going to be able to have access to them, whether that's from a hurricane that comes in and it floods your zone and you can't get access from that supplier. You need to be able to go to another supplier. There's obviously geopolitical reasons that are happening in the world right now. But from an engineering perspective, you learn by doing. And the more accessible that you have making in front of you, the faster we advance our innovation capabilities, that we can create and evolve into what we need next. I've talked to small drone companies that go overseas, and the reason why they do that is I can go in and on an envelope, a piece of paper, a napkin, and draw out what I need, and I have everybody that knows how to make that immediately there and can convert my idea into my product. We cannot do that. From an economic perspective, you're only creating wealth when you make something, send it somewhere else, and have somebody else's money spent on that, and it returns to your system. Otherwise, we're just swapping dollars between ourselves, right? That's what the service economy basically is. That's not elevating the wealth and the buying power of our country. And then from a national security perspective, we're not always certain that where we source those from, that for a number of reasons, that we're going to have access to the raw material or the product that we need to be able to drive our cars or build our submarines. But I think that many countries, as we talked earlier, that John noted early on, decades ago, 20 years ago, we started understanding the fact that our countries that realized that they'd gone too far on manufacturing during the economic downturn of the global recession, those that had manufacturing weathered their economy and were able to rebound faster because they produced product. And so I think from an economic and national security perspective, there's reasons why you want to be able to own manufacturing in your country. But from a community, look at what's happening around Auburn. You have a Korean company that's located here. You have GE that's located here. Danville, Virginia the last Confederate capital of the United States has companies, global companies, relocating to Danville, Virginia, because they have highly skilled manufacturing workforce that are relocating to Danville, Virginia for that workforce. And I happen to think it's cool and exciting to be in it. So for no other reason, countries need to be, we need to be in manufacturing because it is a cool thing to do. So
I'll jump in too. I mean, there's lots of reasons. Jobs. Adele talked about the companies that come here, so good jobs for the American people. But more than anything else, it's the overall. It's a really complex ecosystem that manufacturing contributes to. More than anything else, it's the economy, though. When Thomas Jefferson sent Lewis and Clark off on their expedition, I think he coined the term, "It's the economy, stupid." Maybe that wasn't him. Maybe that was James Carville in the Bill Clinton election. But anyway, he said something like that. He really did. He said, in those colonial terms, he said, "I ye send you forth for the economy," something like that. So, but that's what it's really about. But I said it's this complex ecosystem. So,
wasn't it Alexander Hamilton that said if you need a good Navy, you need a strong fisheries program? Right?
Probably.
I think the same thing.
So, but it's. I think Vannevar Bush said something about when he was establishing National Science Foundation. Maybe he said a country that relies on others for its intellectual prosperity is destined to fail. And advanced manufacturing plays this oversized role in innovation in this country. So that's why it's part of this. I don't know what the elements are of this complex ecosystem, but it's national posture, it's science and technology, it's the economy, all those things linked together. And manufacturing, I think, plays an oversized role in if you look at the number of scientists and engineers that work in manufacturing and patents that come out of I think it's I don't know, these guys probably know the numbers, but 2/3 of the patents come out of manufacturing. Big numbers for advanced manufacturing. So it's a big contributor.
Let me bring it down a few steps closer to home, right? So how many have heard of Maslow's hierarchy of needs? So at the top we have some sociologic needs, emotional, etc. Down at the bottom, what do we need? We need food, water, sleep, etc. Well, guess what? Our food industry is a manufacturing industry. How we deal with the food packaging in itself, the distribution networks, and we have a global food supply chain right now, even in the United States. We get fruits and vegetables and other things globally speaking, depending on the change of season, so we can have stuff year round. Again, going to the pandemic, we saw a challenge even in our food industry, from that globalization. And so if you think about advanced manufacturing and how it plays into cross-sector areas, not just the technologies, which is exciting enough, but we have to understand that it affects every level of our society.
You get a gold star for the question.
Okay. So first of all, thank you so much for the talk. It was very interesting to learn you all's perspective about the future in manufacturing in the U.S. And I guess some of you already mentioned some of the obstacles the manufacturing in the U.S. Is facing. Adele mentioned the working age population, also the global competition, the lack of interest for manufacturing. But I want to hear you all's opinion about what are the main obstacles for reviving the manufacturing in the U.S.
We talked about that a little bit. We had these great discussions this morning before we got here. We should have taped those and played them back. So we talked about that a little bit this morning, and so one of the things I brought up was We have these 300,000 factories or so that I talked about, small, medium factories. They have a culture and legacy, so they have equipment that they've had for a long time. It's hard to, and Chris talked about it a lot. It's hard to make that pivot from a legacy operation to a new high-tech AI-driven robotic kind of operation. Just think about that. That's a tremendous challenge for these companies that have been, a lot of them are, family companies or whatever. They've just got this legacy and this culture. So it's a tough change for them to make. And I think for me, that's one of the biggest barriers for go ahead.
I think it's a systems engineering problem, right? We've spent decades offshoring manufacturing. You guys raised your hand, right? Very few of you grew up with manufacturing around you. At the peak requirement for workers on some of the key, so I'm working a lot with the submarine community, right? The next generation submarine that we're about to lay the keel on in 2 years, it won't fit in Jordan-Hare. It won't fit. It's the largest submarine we've ever built. And yet, the people that we're recruiting are in 4th through 8th grade right now. Right? The peak employment, when we're going to start surging on those people, are in 4th through 8th grade, and yet we don't have a relationship with manufacturing in this country. So the first thing is the workers, right? We talked about Texas. They need 25,000 engineers a year right now coming out of school. For all the decades of work that we've been putting into growing engineers in this country, we still haven't statistically moved the needle. So that entire system, the relationship and presence of manufacturing to society, we are awakening to. There's a reason why you need things outside of you, to look at you, to prompt you to continue in life, right? And we're paying that price right now. And so we're recovering on that in terms of trying to stimulate engineers that understand how to make things, grow more engineers to stay in your own communities, right? So you can sign NIL deals and have a really good football team if that's what you want to do, or contribute to, problems that we face in society. That was a little tongue-in-cheek. Obviously, that fell flat on an engineering program, right? Where's our NIL deal, right? We are the foundational elements, like John said. The role of automation and adoption of technology needs to be at a faster pace in this country, but we don't have the capital. Small companies don't have the capital accessible to them, so that's why the banking and finance community needs to be in here next year. And nor they understand why they need to do it, right? They don't understand it. You got a company around the corner here a few years ago who's like, why do I need to move to 5-axis? I've got 3-axis. It works fine. Yeah, but it takes you 20 hours to make that part when you can make it, in 30 minutes on this, as an example. There's a lot of reasons why that's an impediment. But I do think that the incentives, the financial incentives that we're pushing out to regrow and catalyze and send big demand signals, right? Number one for business is sending the demand signal. Industry will start to spin up when we start to push a lot of demand for product, and then that pulls down that entire pipeline. The question for us, though, as a country, is will we have sustained will? Will we sustain the demand that we're starting to create through these large-scale infrastructure investments that we've been marching down this pipe, been doing for the past few years, where we've really been shoving a lot of money out the door to try to pull at manufacturing, rebuild supply chains here, rebuild capacity here. And really, you have a vote on that. You have a vote as an engineer, you have a vote as a citizen, you have a vote in your voice that you carry on the importance of that. And so systems engineering problem that we need systems engineering thinking on from and sustained will on it, I think, and a sense of urgency about it.
I spend a lot of my time with hundreds of small to medium-sized manufacturers. So I get to see things firsthand. I get to talk to leadership. I get to talk to people in operations. I think a lot of our challenge is culture. I think a lot of people have been doing this for a while, and it's kind of hard to make that leap that, like Adele said, I need to move from a 3-axis to a 5-axis. 3-axis is fine. I've been doing it fine. I'm making enough money. I don't need to make that investment. So I think that's part of it. I think part of it is drive. Again, we have a lot of existing operations that have been around for a while, and the drive in the U.S., in our culture, is not as strong, I think, as it is in other countries where they are willing to make those changes. And I think, part of this is just the legacy we have. Part of it is getting new, fresh blood in, getting fresh ideas in, whether that means injecting them into that existing legacy system we have, or creating new greenfield operations that can bypass those. If you're familiar with Clayton Christensen, he wrote The Innovator's Dilemma. And one of the biggest challenges that any existing company has is it's hard to make the right changes because of inertia, because of culture, because of investments, that quite often a small company outside of that large organization can move much faster and get much farther more quickly. So I think that unless we start to change the culture, especially the culture in existing operations, whether it's a very large conglomerate or even a medium-sized company that's been around for 20 or 30 years, until we can start to change that culture one way or another, I think that also is going to be a challenge.
Speaking of culture, I want to take a poll. Yeah. How many of you, when you say the word entrepreneur or entrepreneurial spirit, which way do you lean on the vote? It's going to be a binary vote here. You get your choice. Do you think innovator or do you think business owner? Do you think technology innovator or do you think business owner? Which one? Let's raise our hands now. Ready? Innovator. Who thinks entrepreneurial spirits are related to innovators, technology pushers, right? How many of you think somebody owns a business? Ooh, this is good. We're shifting. Not too long ago, you would have gotten more, hey, an entrepreneur is just somebody who's out doing cool things tech-wise. I think one of the big barriers in culture that we're going to have to face in this country is we've got to have people who want to be in manufacturing and own manufacturing companies. I can tell you about those that are doing it and doing it well. Mitch Free up in Atlanta, as an example, we need more young people who want to be in manufacturing and want to own their own business.
I'll give you an example that we all know, except John. I don't think John knows, but this is a member of ours, Nathan and USPA. Adele has been to their facility, Calumet Electronics, up in the Upper Peninsula of Michigan, way out. I mean, way out in Upper Peninsula, to the point that you're driving through the countryside and you see signs that say Deer Skull Boiling, which is big in hunting country. So you see that. That's how far out it is. They have a juggernaut adoption culture where they are always looking for new talent, not because they have an open slot and they want the person to perform those roles, but because they're always looking for somebody who is thinking differently, always challenging things. And when I talked to them as part of this program with Dr. Harris, we were doing some research and we wanted to find out, remember the adoption stages? So education and awareness, how are you getting your ideas? Where are you finding out about them and how are you trying them? They're not going to they go to trade shows, but they're not going to the standard industry media. They're on Reddit, they're on YouTube, they're going to all these different places. There are these people that follow that have channels that are tinkerers, that are makers. And they learn about these things, and then they bring them into the office, and they get excited and passionate about it. And as a team, I saw this firsthand. Ashley and I were there talking to them, and they're all going back and forth and talking about these ideas. And if we try this, we'll try that. And in that organization, they are given a lot of flexibility to try things.
privately held company.
And they're a privately held company, so that makes it a little bit easier. But their CEO gives them a lot of flexibility. And if they try something that doesn't work, okay, we tried that, let's move on. We'll take the lessons learned and keep on going. That is part of the culture, and that is one of the best and most exciting cultures I've seen. As you go into industry, as you start going into your organizations, those are some of the things to think about, the kind of place you want to work. Think about the culture, and can you have an impact? Can you take your passion and excitement and take that into the organization, and will it be valued in there?
Well, let me just add to this too. We're talking about people and culture, right? Last year at the Defense Manufacturing Conference, which was in Tampa, and we all tend to go to that, a friend of mine who's retired Air Force, he's heavily invested in STEM engagement. He said, hey, Nathan, since you're coming down, let's go to this NASA-sponsored magnet school at the middle school level, and let's talk to them about electronics. I'm like, great. You know, you visit with these students, and they don't know that they can think differently. They don't know how to apply math and do a simple algebra formula to figure out, well, how much of a battery do I need to light up this LED? Or, hey, let's be creative. And so I brought a bunch of copper tape, you know, you can buy for a few bucks on Amazon, bought some LEDs and coin cells, and we did what the school had was a laminator, right? So we built circuit boards out of copper tape, LEDs, and laminators. They had no idea that you could innovate in just household materials, or, well, what does electronics actually get them, and how do you make them? And so the inspiring the younger generation to think and be curious, I think, is really important. To be innovative, whether it's a business owner or leader, or to think about the science and technology and ways to solve the problem. We have to touch and reach down to those who are coming behind us. That is actually a major gap right now. We see across the country a lot of apathy. And culturally speaking, that's a terrible thing, right? And so each of us take some ownership of that, right? Talk to your neighbors, talk to your friends, and let's inspire them for something very different. And you don't have to have college degrees to really create and innovate in different ways. Work on what's in front of you.
Thank you for the great talks and the responses. I have a question about space manufacturing. So I know NASA has had great initiatives in the past, such as the 3D printed habitat challenge. We're like actively looking for ways to create structures in different planets. So where do you start when you want to plan out, when you need to figure out how to manufacture things in space?
John, you want to take that one?
I'll take that one. I'll at least start. I didn't think that's where you were going with that question, so I was already trying to answer another question. So, but so you start with imagination, probably, for one thing. When you think about what we're going to do in space, I think Einstein said imagination is more important than knowledge. So for some of these things, that's where you start. Let me tell you about that 3D printed habitat challenge that I think that you referenced. That came from some of I helped to start that, and so it came from, it wasn't my original idea, but it took some imagination for us to come up with what we were asking. NASA's next great adventure is really about this sustainable presence on the lunar surface. It's hard to sort of grasp all kinds of activities on the lunar surface. Giant lunar outposts, lots of people living and working on the lunar surface. So you've got to begin to think, what are the objectives? What are the requirements that are going to allow you to build and have all these activities? You're going to need things like, power, and you're going to need, if you run a town here, it's like the utilities. You got to have, those same kinds of things to sustain that. But it's different on the lunar surface than it is here. You got to really think in a more sustainable fashion. And what I mean by that is more of a circular life cycle of how you utilize materials. So we're talking about using materials like the lunar regolith to build things when, to make and construct things when we get there. I don't know if you know, but we don't do a very good job of practicing sustainability in manufacturing today. By the way, that's somebody mentioned Industry 4.0 earlier. There's this new Industry 5.0, maybe it's not new, but Industry 5.0, and it's the Industry 4.0 was the digital transformation. Industry 5.0, so a European idea, adopts sustainability as another element of that. And so we don't do a very good job of that here in this country. Some places we do. If you take a aluminum can off the shelf at Walmart today, in 60 days, that aluminum can has been recycled and turned back into, a soda can, and it's back on the shelf again. So in aluminum, we do a pretty good job. 60% of the aluminum that's ever been, mined, manufactured is still in use today. That's not true for most things, and so we don't do a very good job of manufacturing sustainability. But I didn't answer your question. You start. We have we've outlined 63 objectives for this lunar sustainable approach. And we start there. We take all of those and decompose them down into how we actually implement a plan like that. And so manufacturing in space is part of that. Part of it is to build roads, landing pads, habitats, using lunar regolith. Other parts of it is different kinds of manufacturing to build. If we're going to have a lunar, there's this talk of a lunar economy. So if you're going to have a lunar economy, you got to have more than just utilities. You got to build and make things, right? And so that's part of in-space manufacturing. We're just getting our toe in the water into what that actually is. Additive manufacturing, for me, has such utility for an in-space manufacturing process. And so I think we're going to do a lot of 3D printing and additive manufacturing in space. In fact, that's the first in-space, experiment that we did in 2014. We put a 3D printer on the International Space Station. So.
Yeah.
Thank you.
You're probably in a much more, is it fair, pristine environment when you're doing that? And we're on the opposite end of that spectrum. When it comes to additive or advanced manufacturing, if you've walked these labs around here, right, there's uber clean. Heck, I can eat off the floors, right? They're that clean. So just down at the laser lab, it's clean. Down at the additive lab, it's clean. Pristine. In fact, some of those materials need to be environmentally controlled, but that's not the way. If we have to go fight, that's not what happens in the fight. You don't have clean. So, we're thinking through how do you take these great advanced manufacturing capabilities that have been developed in these clean capabilities, which you need normally, right, for normal operations to produce products every day. But there's going to be moments when it's not so clean. And so how do we adapt those in an unclean environment, right, where you've got bullets and heat or no power or not enough power or dust and corrosion from salt spray. I don't know how thick the concrete is downstairs in the basement of this building, but it's certainly thicker than the plate on a ship that's rolling on a 12-foot sea state, right? So these are the challenges that, on the other end of the spectrum, that we're looking at in terms of the utility of advanced manufacturing.
So my question my question is about how are you taking into account global trajectories and national trajectories like tackling climate change or the expansion of the middle class and respecting labor rights with the creation of this neo-industrial revolution, this manufacturing revolution? Is that something that's even a priority?
Boy, I got to have a great meeting up in Huntsville yesterday with an individual. He's been in the electronics industry for a long time. He's been in over 100 countries, worked in a handful of those. And he was telling me a story when he was in Malaysia, when he worked there. The culture is very different, right? And so because of the globalization of our supply chains in multiple sectors, not just electronics, but multiple sectors, we have cultural differences and the priorities are different. So when we think about sustainability in the European Union, in the United States, it has a very different meaning when you're in Southeast Asia. And again, the cultural priorities can be very different. And some of those countries, they really just want to build something high quality and have return business. In other countries, say you go to the Philippines, their industry for operating call centers, that's their global sourcing to actually most of the Western countries. If you call up, American Express, Discover Card, any of these, even T-Mobile, other countries, you'll invariably get a call center in the Philippines. But again, how they deal with those challenges in that middle class workforce, or towards manufacturing is going to be very different. So I don't have an answer for your question. I think it's really highlighting that it's a very complex set of variables, I think, that are out there.
The National Academies just did a study for us about this lunar exploration initiative that we have, and they came back and their real priorities back to us were around sustainability, these circular, sustainable life cycles for materials and biologicals and all those kinds of things. And for when you read that, it was really directed at space exploration, but you really should reflect that back on what we're doing here on Earth. We don't have a great political climate. We make our decisions based on economics, and for those reasons, I think we're a little slow to adopt the kinds of we're not making policies that would require us to move in those kinds of directions, where other countries are making policies that require them to move. I don't know. It's a great
question.
I think it's really important. I just want to say I think it's extremely important. I think it's one of those existential threat kind of things that we're going to have to address.
I mean, there's reasons why certain industries are overseas now, right? Because the technology was not affordable to make it easier for U.S. manufacturing to say, we'll do it here. Look, we like clean, at least I think we do. We like clean air. We like clean water. We like to know when we turn on our tap that it's safe to drink. And I can remember growing up where the rivers looked like coffee because of the chemicals that were being put in them. And we decided we didn't want that anymore, right? And there's some industries that are more caustic than others. But technology has a play. And this goes back to the discussion we were having earlier. Know while we're doing something, right? Whether it's buying down the workforce load so a person can work 40 hours a week, not 70 hours a week to produce it, or whether it's being able to produce the products that we want here without having to make the sacrifice of clean water or clean air or other things that we're, right now making trades on. But technology has a play. I was just looking at something not the other day. I was talking about, and I can remember I did a lot of flight testing out at Edwards Air Force Base, and I would fly into Los Angeles, and you'd see the big yellow smog layer. That's not like that anymore. Why? Because we've made affordable technology that scrubs and cleans things. It's not spewing stuff out the stacks anymore, but it didn't drive people out of business. And I think that's where engineering and manufacturing come into play. And I think you can have it both. I think you can have your cake and eat it too when it comes to being able to make things here and honor the other values that we also hold in our society. I don't think we have to I think we have it within us to do that. And perhaps I'm more optimistic in who we are as people and the capacities that we have in engineering in this country and resources that we have to do that if we have the will to do it. But I believe that we have it. But that's a great question.
Great question.
Yeah, so here's my take on this. I think, like Adele said, I think we're starting to get reversed a lot of the issues that caused us to push things offshore to begin with, right? So your question is the impact of global issues, what's going on. It's not just climate. We look at what's going on in Ukraine and Israel and everywhere else. We look at the potential of being held hostage because we rely on certain countries or regions for certain products. And from my standpoint, it's an issue of national security. We can't allow the country to be put in a position where we can be cut off from something, where we can be reliant on some other region and we have no means in this country to produce it. Nathan brought up before the iPhone. There are so many things that we cannot make here in the US that if we lost access to not just the end use technology, but even the underlying components that go in those systems, we're in trouble. So I think that we got two things coming up. I think a lot of these issues that caused us to go the direction in the first place, we've been figuring those out and we've been turning the corner on those. Climate change being one of them, and how do we do things more sustainably and cleaner. So I think we've got that on the right track, but now we got this big stick right behind it that we need to figure out how to do this because there is a threat to us as a country, as a people, and it's not just us, but others around the world as well. So I think those things, those global issues are coming together to drive us to say, now's the time to do it. We need to figure out how.
You got a question here?
So my question, really just you've spoken a lot on overall just the reshoring effort, how your organizations are working with expanding advanced manufacturing here in the United States. And you talked a lot about the manufacturers themselves, changing the culture, getting them to adopt these new technologies, our individual places as engineers and as citizens, and a little bit on the university with not sitting on new technology, actually getting it out there. But my question I really want to hope you all can answer is, as a land-grant university, we're supposed to be reaching out and working with the community as well. Where do you see organizations like Auburn University as an entity playing our part in the overall plan that your organizations have for the advanced manufacturing future for the country?
Well, I graduated from a land grant. I believe if we go back and read the charter of the land grant, right, when they were established and why they were established for the people, for the society, with the needs of the state and the people within the state. Now that started around an agricultural type perspective, at least from where I, over in Mississippi, and I think probably Auburn too. But we evolve. And I think the land grants can play and should play a special leadership role in the challenges that we face on restoring manufacturing in this country. That's my opinion. That's not the department's opinion. That is my opinion, having, come from that system as one like what you have here. And you're leading, right? You're leading in that space. Auburn is, as a land grant. You're leading on advanced manufacturing. You leaned into the ICAMS facility. Were you the first? No, necessarily, but you're definitely not the last, but you're doing innovative things through them as well. Like one of our things on workforce is we believe that there should be a strong relationship between the engineering program and the technicians down at the community colleges. That's one of the challenges, right? The community colleges are they're training on one machine, and you're maybe not training on any, depending on what university you're at. Here I applaud the mechanical engineering department that they run them through machining, but many universities don't. And so Auburn is leading in that space. You have access in your undergraduate to make. It's aligning to the same equipment that industry is using. You're doing advanced research on it. You're helping industry to adopt it. You're helping to grow your community of manufacturing here. And I think then the next step is to link forces with other universities in the region to, I'm not as smart as you guys, so I have to use analogies I'm more familiar with. Sod, when you're having to plug your yard, you use sod plugs and they bridge across each other, and before you know it, you have a mat of grass. And I think that's what we are trying to do in this country, is to find people like what is here and link you together, and together we are better, and then to go off and help other people become their sod plug in their yard. Did I answer your question? It's been a long day.
So it is a tough question. But I'll tell you what you guys are lucky. I'll tell you what you do have. And I mentioned it to the dean. We had lunch with the dean today. You have leadership. Leadership sets the core values for whatever, and they promote those core values. And your leadership, I've worked with Dr. Taylor, Dr. Roberts, the dean. Your leadership has said, hey, advanced manufacturing is going to be one of our premier, initiatives, and they get behind that, and that allows all of us from the grassroots efforts to be able to go and do that work. I'll give you an example. Adele gave a great example with the. Did you say zoysia?
No, I did not.
I don't know. I don't have any zoysia in my yard, but with your additive center, Dr. Shamsay and your additive center started off as a fairly small effort, but the leadership was behind that and did the things that allowed it to grow. Are you familiar with the additive center? Really familiar with it? Look at where they are today in a very short amount of time. It's just amazing to me. In a very short amount of time, about a little over 5 years, Auburn's one of the world leaders in additive manufacturing, especially for these highly. At NASA, we use additive for liquid rocket engine propulsion parts. So these highly critical. I mean, we had a tour today, and y'all's guys have an understanding that is not found in most universities, not found in most industries. But collaboration is a part of the secret sauce for all that. Just next week is the ICAM conference. There's a lot of ICAMs around here. International Conference for Advanced Manufacturing, used to be additive manufacturing. More than 1,000, and Dr. Shamsay's the co-organizer for that. I'm one of the way down the line organizers for it, but he's one of the co-organizers for that, together with Mohsen Saifi from ASTM. More than 1,000 people are going to come to that. So y'all have built this tremendous worldwide platform for additive in just around 5 years. And I think it all goes back to the leadership. Is that was one of their core values, and they made sure y'all could make that happen, that we could make that happen. So.
I'll go back to something that Chris had brought up, an example in South Korea, where the government invested in these 19 demonstration centers. They probably have a different term for it, but again, what you're doing here at Auburn is phenomenal. When you think about the regional aspect here in Alabama and in Georgia and just really around, that outreach of, hey, showing a company what could be done, what they could do towards that adoption. Again, if you know the priorities that we need to be faster in our manufacture with more precision, more high mix of different things, how are we going to get more companies involved with that and stimulate their own innovation and their own regional economies? I think that land-grant university has a part of that responsibility and outreach, let alone the outreach towards the next generation of STEM professionals too. And that STEM professionals is not just engineering degrees, by the way. It's those who will be working on the floors, engineering, design. I mean, innovation can come from all kinds of places. So.
I'm going to take this a little bit different direction, because you mentioned something about land-grant universities supporting the community, right? Giving back to the community. So if you look at what's been going on in companies, starting with the large companies and then trickling down to small to medium-sized companies for a while now, a whole effort around ESG, environment, social, and governance, right? Environmental. And a lot of it is companies starting to think along those lines that they need to be good citizens. They need to be helping provide for their communities because their communities are providing for them. So as you go out and you start getting engaged in industry, that experience that you're getting here, that idea of supporting a community, I think helps carry through into industry. It kind of sets you apart because out of all the students I've talked to before, I've never really heard somebody talk about, from a school perspective, the idea to support a community. And even if you go to the small to medium-sized companies, we find a lot of companies are really tied in much more closely to their communities than we had seen, even just 10 years ago. So I think that's an interesting aspect to bring to your career.
We got time for one more question.
Y'all have good questions.
I'm
Great.
a loud person, so I'll just talk. So I'm Madison, and I'm doing research in cybersecurity, cyber-physical security, and I was kind of interested that hasn't come up at all.
Oh.
So I was kind of interested to get this group's take on it and how that's going to play a fact into pushing these technologies, because we want to have them, but we also want the small and mediums to be secure with their intellectual property.
That's a great question. About, let me think, when did I do this? Eight years ago, I led a study under Department of Energy entering cybersecurity and manufacturing test. And again, towards electronics, if you think of cyber systems, you're building things with chips and processors, you're adding software into that, you're testing the characteristics, and it's all semi-automated. That also might be the point of where malicious insertion could happen, or you cycle something over voltage it shorts out and you've blown it. And what's the last thing that told you it was good, right? But it was really not good. And so this whole idea of considering cybersecurity in this data-rich and highly autonomous environment is really important to consider. The adoption is a challenge. So about 2 years ago, this topic came up more mainstream. So there's a group within the Defense Industrial Base called the DoD Manufacturing Readiness Level Working Group. And so I got to pull my old team together from the Department of Energy. I wasn't working there anymore, but we pulled them together, talked with some government leaders and say, okay, we'll put the perspectives we learned from that study in. And the folks in that working group were great, but then you had to get some sort of collective agreement. Well, what's our lowest point of entry to get it into a standard? That's a challenge. But the reality is, and from studying cyber, the problem has gotten a lot more complex these days, from a combinatorial perspective. And so if everybody goes into the idea of manufacturing with autonomy, that we always need to bring our partners in cybersecurity because it affects our reliability, it affects our test systems, it affects the precisions and the recipes. Bring your buddies along because it really is a cross-disciplinary challenge that we have to address. Now, unfortunately, there's a few manufacturers out there with control systems that have these, we'll say, a bump-in-the-wire secure devices. Schweitzer Engineering out in Idaho and Washington State have something like that. We see it also in the energy sector in their control system, these little miniature secure devices. But it'd be better if we built them in. It'd be better if we had these cyber IT perspectives also tied to your SCADA control systems as well in a better way. But there's always going to be a little bit of push and shove back and forth between more highly secured and more enabler and manufacturing. But that's where that open conversation really needs to occur, and we got to do it together.
Yeah, from a policy perspective, we're highly concerned about cybersecurity for manufacturing. In fact, we co-sponsored the topic as one of our federal studies because there was so much focus on cybersecurity just from an IT, like how to protect my computer, and there was not any discussion at the time ongoing about your manufacturing shop floor. Going back to the 300,000 small and medium manufacturers in this country, 80% of them are less than 20 people. So you're asking 20 people to fight off nation-state actors. Huh? Really? They're just trying to figure out how to move from 3-axis to 5-axis, and now we got to add, hey, dancing bears to your list. So very concerned about it. And then to further complicate it, most small and medium manufacturers don't even understand why they need to care about it and that they are a target. So, how did we get here today? We rode a scooter, we got in a car, we may have flown. Why did you do that? Why? Why did you get in a car or fly on a plane or get on a train as your mode of transportation to get you from point A to point B? Because you probably had confidence that it was going to get you from point A to point B. But cybersecurity, never mind the normal supply chain issues that can disrupt that, or material characterizations that we're talking about. The biggest threat for a small and medium manufacturer could be the fact that somebody comes in and basically forces them to produce a counterfeit part. They don't know it. Never mind the intellectual property theft that could happen through that process, or now hostage, right? Just pure hostage taking. Give me $50,000 and I'll let you go. Very concerned. But the challenge is, how do you implement cybersecurity capabilities so that it makes it it's easier for those companies to adopt? It's either embedded and naturally inherent to the system in a balance with what you need it to do, or it's easy for them to monitor and execute. We're concerned about this even on our shop floor technicians, because right now the biggest threat is the insider threat, right? The human that walks in and does something either nefariously or unintentionally. But we're introducing in our Project MFG competition, which you guys have participated in, introducing a cybersecurity aspect to that. That's a team competition. It's mainly community colleges and high schools right now, although we've had universities compete in the manufacturing part of it, SEC manufacturing, a little over 3 weeks from now. It's welding, at 5-axis machining, CAD/CAM metrology, making high-end parts, right? So now we're going to introduce a cyber component to that so that the folks in the CTE world, right, that are going to be making parts on the shop floor begin to understand that you play a role in this. So that's an educational campaign as much as a technology and adoption learning process for us as well. Great question.
Madison, it's kind of interesting because, again, I spend a lot of my time with small to medium-sized manufacturers. You have that existing infrastructure. I know one company that has 23 operating systems on their floor, including 3 versions of DOS. They've got 15,000 jobs on the floor at any given time. So it's a highly complex environment. You're not going to add software onto their operating systems, and to change that is going to require a significant capital investment. So you've got that issue. Then you've got this whole thing with, most of the time in IT, when you think about cybersecurity, you think CIA, confidentiality, integrity, and availability. In manufacturing, in the OT world, it's availability, integrity, and then confidentiality. Those machines are running. Those machines are making money, keeping us working. You're not going to mess around with them. So, as you look at tackling that problem, and I'm not sure what direction you're going, there's this forward-looking one where, okay, we got new machines coming down the line. How can we embed cybersecurity in them? And then what Nathan was talking about, are there solutions that we can put in place that don't require wholesale change of equipment and operating systems without a high cost? I actually testified before the Senate Armed Services Committee on this a couple of years ago, and the point I was making is that the pending requirements for CMMC, the Cybersecurity Maturity Model Certification, which is going to be imposed by the DoD, if it is not addressed properly, it's going to push companies out of supporting the Department of Defense because they can't afford it. And like Adele said, they don't understand. We have done a very poor job of educating them of the importance of good cyber hygiene. It's not just if you're dealing with the U.S. government, for your own company, for your own security. If you get hit with ransomware, there are so many examples of how much that costs you. We need to have done a better job of educating companies, and we're still working on that.
We have come to the end of our time. Would you give me help me thank our guests, our speakers here?
You guys are the ones to be applauded.
Yeah, I know. Great question.
Plug in if you can come out to ICAMS at 1:30 tomorrow. We're going to have a grand opening and open house. You're all invited. Thank you. Excellent.
Nice.
Thank you.
Thank you.